Welcome to Cryptography session. Today I am going to give an introduction about elliptic curve cryptography algorithm. So we already know the calculations of elliptic curve. So if any elliptic curve points are given and we can do addition operations by calculating the slope values. So these are all the way we can do the problems in elliptic curve. So let us take the values. So if you take curve may be two types. Either it may be a prime number curve or it may be the binary curves. Primary curves are denoted as ET of A comma B. So we should calculate it for ZB and we do modulus operations here. So in this way only the calculations were done at previous class. And the second point is we may able to do binary curves. So instead of P, we may able to substitute 2 power M. So it is represented with the Galois field. So we already know the Galois field value. So we should do a polynomial equations for doing addition operations. So if you want to do the implementations in software, prime number calculations is the best solution. So let us discuss the notations. So I already told that elliptic curve cryptography is a public key crypto system implementation. So there is a need of finding the private key and public keys for the users. So let us take the private key as K, and using that private key K, the public key is calculated. So the points on curve is equal to private key value K into G. So that is the public key value. And what are the set operations that can be done means a generalized form of equation is y squared equal to x cube plus ax plus b. And the domain will be given. So it is a given point G. So here we denoted as it is a prime number with 2 points. So using that notations, you may able to write the equations here in which the condition is 4a cube plus 27b square, that should be not equivalent to 0. In this way, you should use A and B points. And we are doing only modulus operations because we are taking the prime curve. So what is an elliptic curve cryptography? It is a public key crypto system in which there is a need of calculating public key and private key. We already know that public key is used for encryption and signature verification process. And we are using private key for decryption and signature generation purpose. So this is the points that should be noted out carefully, because all public keys are only used for encryption purpose, and if you are using that public key for signature, it is verified. So the verification is done at receiver side. Encryption means it will be done at sender side. If you are using private key, decryption is done at receiver side. Signature generation is done at sender side. So if you generate a signature by using private key, that is called as authentication. So authentication is only done at sender side. So these differences should be known to you. Then only we may able to implement the public key encryption concept or an authentication mechanism. So depending upon the requirement of the user, either we may implement a confidentiality or an authentication. Confidentiality is the encryption decryption. Authentication means the signature generation and verification. And we may able to implement this elliptic curve based upon either a Diffie-Hellman key exchange algorithm, otherwise a digital signature algorithm. Currently, we only know about a Diffie-Hellman key exchange algorithm. So I explained this elliptic curve algorithm based upon the Diffie-Hellman key exchange. This digital signature algorithm concept will be discussed in Unit 4. So after that, I will give the explanations for this one. So I will give this topic up to you. So one day I am giving the explanations of elliptic curve implementation based upon Diffie-Hellman key exchange algorithm in this class. So how to use an elliptic curve in your cryptography? This is the major big question. So the central part of any crypto system involving elliptic curve it is denoted as an elliptic group. So group means G. So here we are taking the prime number. So ZP. So ZP with operations. So you can do either multiplication operations or addition operation here. So for all public key crypto systems, we should use some mathematical operations. We are aware that three different algorithms, public key crypto systems are available. One is RSA, second one Elgamal crypto system, and third one is elliptic curve crypto system. If you take RSA and Elgamal crypto system, on those two algorithms, the encryption and decryption is implemented based upon exponentiation mechanism. So we should do exponentiation operation for implementing encryption and decryption at RSA and also in Elgamal system. But if you take an elliptic curve cryptography, it has a collection of points. So we are only implementing a multiplication operations on ECC. Instead of multiplications, we are doing addition operations. Let us take P and Q are 2 points. So we can do R is equal to P plus Q, or we may also able to do R is equal to 2 plus P means P plus P. If R is equal to 3P means we can able to do addition operations. So instead of multiplication like 2P or 3P, we may able to do addition operations. So this is the easy mechanism of implementation. So let us take the general concept. So in an elliptic curve equations, they will give 2 points with a prime number. So it is denoted as a group. And there is always the need of base point B. This base point B will be taken from an elliptic group. Generally, it is a prime number P. And we should calculate public key and private key values from the given group and those points. These keys are implemented for doing encryption and decryption. So let us take a private key K. So that is an integer. The integer value should be from 1 to P minus 1. So if you take a prime number P in a group denotation, the private key value from 1 to P minus 1. So after selecting private key, we may do public key calculation. So public key is equal to the private key value into base point. So here B is the base point value. So let us take EP of A comma B. So this will be the base point value. So this is the general calculation. Then for implementation side, let us take Alice want to send information to Bob. Here Alice is a sender, Bob is a receiver. And we are trying to implement this elliptic curve crypto system based upon Diffie-Hellman algorithm. So let us take that algorithm in a review. So in a Diffie-Hellman algorithm, we are taking private key is NA and we do calculation of public key. So PA is equal to NA into B. At the receiver side, private key is taken as NB. So public key PB is equal to NB into B. Then we will exchange the public key and private key values for implementing encryption process. So let us take the cryptographic representations. Here we should select a random integer k. So this k number range is from 1 to p minus 1. So the encryption is done. So PC is the encrypted value, which is a set of two values. The first value is the random number k into base point, and the second value is the given plain text value PM plus the random number k into PB. So here PB is retrieved from receiver B. So this is the encrypted pair. We are in need to do decryption. So for decrypting, receiver compute the value KB with the help of his own private key. So I already discussed that private key is used for decryption and signature generation process. Here Bob used his own private key for decryption. So NB, so he received two values. Bob received the first value KB and the second value PM plus K into PB. For using the first value, he'll try to calculate the generalized form. So by applying his own private key, the first value is reprocessed as NB into KB. And he will subtract that resultant value from the second one. So the second parameter is PM plus KB, K into PB. Then the calculated value should be subtracted. So I am writing it as minus of NB into KB. So we expanded here. PM plus K. PB means NB into B. Minus here also NB into KB. So these two values are same. So you can this is the plus positive value, this is a minus value. So if you cross check it out, the final answer is PM. So this is the elliptic curve crypto system. So Bob then decode PM from the message. So compare to Elgamal crypto system. In an Elgamal, we are only writing as an exponent formula. So instead of KB, you can also write it as G power K mod B. So here G is the group representations. So K is the random integer that will be selected by user A, alias. The second is PM plus K into PB. So this will be rewritten as M into PB power K. So either using this formula also you can do it. So the first notation is PM plus K into PB, that should be subtracted from B into KB. So I am writing here BM plus K, PB means NB into B minus this value is available. If you cross check it out, this answer is same. So this is the normal Diffie-Hellman algorithm. Instead of this value, if I am taking this one for decryption, G power K mod P, M into PB power K mod P. So I am writing it as the first value, that means M into PB power K, and the second value means G power K whole to the power B. So here B is the Bob's private key. And this PB can be rewritten as G power K into B. So PB means G power B. So it will be rewritten as M into G power BK divided by G power KB. So if you cross check it out, the answer is M. So this is the way you can do it. So the elliptic curve crypto system may be either implemented with a generalized Diffie-Hellman algorithm, or you can use a Elgamal algorithm. The easy way is your implementation should be in a Diffie-Hellman way. So that only we can do a simple arithmetic operation. But if you take Elgamal crypto system, we should only do exponentiation. For avoiding this exponentiation only, we are going to elliptic curve. So better you do elliptic curve crypto system with Diffie-Hellman notation. So this is the overview of Diffie-Hellman based elliptic curve crypto system. So we can do key exchange at Diffie-Hellman algorithm. So user select a suitable curve E, P of A comma B. Select a base point. Here instead of capital B, I am using G. So base point value is x1, y1. It is also a given value. Then A and B should select private keys. So NA should be less than N, NB should be less than N. Compute public keys. So PA is equal to NA into G, PB equal to NB into G. Then calculate shared key value. K is equal to NA into PB. So this is calculated at user A. So KA is NA into PB. KB is NB into PA. So I am writing it as this is KA and it is KB. And we want to prove whether these twos are equal. So let us take KA is equal to NA into PB. So instead of PB, I am substituting it as NB into G. Then this will be rewritten as NB of NA into G. So we already know that NA into G is nothing but PA. So NB into PA is KB. So therefore KA and KB are equal. So now I know the private key values, public key values, and the random number KA. That means secret key which is implemented for encryption decryption process. So this is the step. So EQ of A comma B, G is the base point value. So either you can denote G or B. So it is a base point of elliptic curve. Then NA and NB values are given. So in your problem, they will give NA value and NB value. You only calculate PA and PB by yourself. So formula is PA is equal to NA into G, PB equal to NB into G. And you cross verify the secret key value K. Then for doing encryption process, K is the calculated secret key value. So we already calculated the K value. So either you can substitute KA or KB value here. So G is the base point value, PM will be the given plain text message plus K into PB. So this is ciphertext value. So these two values are equal. So if you verify it by substituting the values, you can able to get PM at decryption side. So in a problem, they will give all these values and we are in need to calculate ciphertext value CM and the session key value K. So let us discuss the problem in next session. Thank you.